In this video, we're going to look at backtracking. So to understand what backtracking is, it is basically an algorithmic technique for solving problems incrementally, mark solving problems incrementally, and by trying all possible solutions one by one. So it tries all possible solutions one by one and it solves problems incrementally. That's a key thing to note here. So the key idea when we talk of backtracking is that if one solution doesn't work, you backtrack to try another one. So it's like you're exploring all possible ways that you can solve a puzzle, and then you undo the steps that some steps rather when you hit a dead end. Now, a real life analogy that would help us understand backtracking even better is imagine that you're in a maze and you're trying to find an exit, right? So again, you have a maze that looks, okay, this is just a silly example of how a maze would look like. And there are a lot of places that are, we will understand what a maze looks like. And this is probably now the exit. So you are in a maze and you're trying to find an exit, right? So let's say you have a lot of so if you are somewhere here and there are multiple doors somewhere here where you can go through. So the for you to try and find an exit, there are a few things that you're going to do, and we'll just write them here one by one. So first, you're going to walk down a path. So you have to choose a path that you're going to go to. So let's say you have to walk down a path. So as you're walking down this path, if the path leads to a dead end, you're going to backtrack or you're going to go back to the last decision point, right? So if dead end, so if you hit a dead end, you backtrack to last decision point, right? To the last decision point. So where you had made the decision to go ahead. And now the last thing that you're going to do there is you're going to try the next path from that point, and you're going to be repeating this process until you find an exit. Right? So basically, we just say repeat till you find an exit. Now, this is what backtracking is. You are exploring all possibilities and undoing any incorrect steps that might come up in that process. So how backtracking works, we're going to just see step by step on how backtracking works. Right? So let's just write it here. So how backtracking works. So how backtracking works, the first thing you need to do, just like when you're in a maze, you have to make a choice. So you have to take a step forward in the solution. So first you need to make a choice. The second thing you need to do is check if the solution that you have is valid. So basically what you're asking yourself is, does this step lead to success or is it a dead end, right? So check if solution is valid. That's the second thing. The third thing you're going to see now is if that solution is valid, you're going to move forward. So you're going to continue exploring any further steps that are there. So if valid, basically move forward or continue. The next thing you're going to do is if the solution that you had chosen is not valid, you're going to backtrack. So you're going to undo the last choice that you made and try a new one, right? So if not valid, backtrack and try again. Now, once you've done this, the only thing that is remaining is for you to just repeat until you find a complete solution or after you've tried all possibilities. Again, it doesn't mean that you're going to arrive at a solution at every moment, but you're basically going to repeat until you complete the solution or you try all possibilities. So let's say repeat until solution or try all possibilities, like that. So that is basically how backtracking works, right? So possibilities, I need another S here. It's okay. Yeah, so that is basically how backtracking works. And the common use cases of backtracking, and from what you've mentioned before, so you can basically see that backtracking would apply really well if you are a Sudoku solver, or if you're solving Sudoku. You have to play numbers. For example, in Sudoku, you have to play numbers in a 9 by 9 grid. And if a number breaks the Sudoku rules, you undo and you try another one. Right? So an example is if you put 5 in a cell, if it conflicts with the rules that are there, you basically backtrack and try maybe 6 or any other number. So some of the use cases, let's write them down here. Actually, I'll just have them here on the side. So I'll just move all this so you can have everything on, around one place. So basically, use cases. These are the common use cases, or basically I just say use cases. So the first thing is Sudoku solver, and you've seen how that happens. The second thing is basically a common problem in data structures and algorithms, which is the n queens problem. So we have the the n the n queens problem. And to understand the n queens problem, basically you place n queens in an n by n chessboard so that two queens basically, or rather so that no two queens attack each other. So if you've played chess before, you understand all the chess rules that apply. So in the n queens problem, you place n queens on an n by n chessboard so that no queens attack each other. So an example is if you place basically you place a queen in a row on a row, and if it conflicts with another, you backtrack and you try another a new column or another column. Basically, you just change your play in case such a thing happens. But yeah, so that's the n-queens problem. At some point, we're going to also have a look at it in details. The other one is what you've just mentioned, which is the maze solving problem. So for when you talk of the maze solving problem, here you basically need to navigate through a maze and try all the possible paths that are there. So if you hit a dead end, you backtrack to the last interaction and you also try a different path. So we've already seen that. And the other one, which could be a bit more obvious here, is when you want to generate all combinations or basically permutations. So when you talk of permutations, an example is if you are to generate all the possible combinations or permutations of three letters. So let's say you have three letters from say A, B, C, D, or even three numbers 1, 2, 3, 4. If one combination doesn't work, you basically just track and rather backtrack and explore others. And that is an example of where backtracking is used. Basically, simply what in terms of a pseudocode, ideally what you've written here can give you a good step into rather good anchor into how you can represent backtracking in code. But we'll just write a simple pseudocode here for backtracking. So let's say we have pseudocode. So the first thing you need, of course, we need a function. So let's say we have a function called backtrack. And the function checks into things. So the choices that someone has to basically make. So we have choices and we have solution, right? So these are basically, again, from how backtracking works, you have to make a choice, then check if the solution that you have is valid. So after doing this, the function, the first thing you need to do is check if the solution is complete or if valid. So if is solution is complete, okay, if that solution is complete, you're basically going to just print that solution and return. So that means you found the valid solution. So print solution and return. Now, else, in case that is not, you haven't done that, you're going to go and try other choices, right? So you're going to need a for loop here. So basically or rather an iteration, basically, since you're not writing the code. So for choices for choices, for each choice in choices, you have to make a choice. So you have to make a choice. So let's call this just make underscore choice. So after making a choice, the other thing is you need to backtrack if you've hit a dead end. So backtrack, and for you to backtrack, what you need the choices, of course, and you need the solution plus choice. The solution and the choice that was made. And you basically, again, how to backtrack once someone has made a choice, you just undo the choice. So you can just say undo choice. So you have make choice and undo choice, and you specify the choice that you want to undo, like this. Again, this is just simple pseudocode for backtracking, but even from how backtracking works, for all the steps that we've looked at, it should be clear how you can implement backtracking in code. And yeah, that's basically it on just a simple introduction to backtracking. I'll see you in the next video.